Welcome to the project demonstration of fault identification system by using Arduino along with IoT. So here the main application of this project is we are going to identify the faults like open circuit fault, short circuit fault, as well as the same data continuously monitor the voltage, current and the fault intimations on the laptop through serial communication, and the same data will be stored into the Thingspeak using ESP8266 Wi-Fi module. So here mainly we are monitoring the voltage levels at 5 stages. So these are resistors are utilized for the voltage dividing purpose. So in the 5 stages 1, 2, 3, 4, 5. So total 5 stages we are continuously monitoring the voltage, and this is a V1, V2, V3, V4, V5, and the next current I1 and I2 at the starting and ending point of this system, and continuously load status, that is nothing but the open circuits or short circuits or else normal. When the load was connected, it's a normal status, and when the load was across the load was got short circuited, then it's a short circuit fault, and when the load was disconnected, that is the open circuit fault. Totally these 3 faults will be identified at the load section, and the continuously current and voltages will be monitored on this LCD screen, and the same data sent to the laptop through this serial communication. And here the major components are like we are providing the 2 power supply sources using these transformers. 2 transformers are the input to this 2 regulated power supply board. So this is the voltage source 1 and this is the voltage source 2, and from there the data will be monitored with help of these 5 voltage sensors which are 10:1 potential divider voltage dividing ratio. These are 10:1. Whenever the input voltage to the voltage sensor is a 10 volts, then the output from the voltage sensor is a 1 volt, as we will multiply that with the 10 inside the program logic. And whenever the fault got occurred, then we'll get the buzzer alerts to this buzzer board, and as we discussed continuously on the LCD screen, and this is the breadboard to distribute the 5 volts power supply throughout the modules. So the 5 volts power supply is getting from this regular power supply board, which is a source 2, and source 1 directly input to the so-called source input section. So here we are using these resistors as 330 ohms 5 watt resistors we are using, and 2 current sensors are like ACS712 current sensors, and 3 loads we are using 12 volt 1 watt loads we are using. Let us see the demonstration. So before demonstration, first of all we need to on the hotspots. So for that, just configure the hotspot name to project, and the password should be 123456789, and AP band should be 2.4 gigahertz. After enabling the hotspots and data, log into the Thingspeak cloud platform. So this is the previous data which we have received. There we are storing the 5 parameters with 5 graphical presentation, that is 5 voltages, and the next 6th one is the load 1 status. So load 1 status 0 nothing but no fault, 1 nothing but short circuits, -1 nothing but open circuits. Same for load 2 and load 3. So if you want to get the fresh data, we can download this and we can erase this. So before erasing the data, download the data. For that, go to data import export, and there we get the download the data, and that will be stored in Excel sheet format, and it will consist of date and time and number of samples till now collected, and exactly fields. So the field 1 is a voltage sensor 1, field 2 is a voltage sensor 2. Like that, it is continuously monitoring along with load statuses. Nothing but 1, as we say, a short circuit, -1 open circuit, 0 is a normal, no fault. So after you took the backup, now go to channel settings, and then only do clear channel. So after channel got cleared, then go to private view. Right, okay. So the old data got erased here. So now initially first is on the power supply to this. Right, on the power supply to the kit, and now connect the Arduino to the laptop and open the Arduino IDE. Right, okay. So once successfully done, welcome message V1, V2, V3, V4, V5, I1, I2. Okay, and if you see fault occurred, then we will get the alerts on the screen of LCD. Right, okay. So in the laptop also continuously we are going to get this I1, I2 and also called status of the load as well as voltages. Now let us make open circuit fault, right? So L1 open circuit, and here also we can see the L1 open circuit, and L1 value is 1. So open circuit is a 1. Now let us do the L2. So you can see that right. Okay, so you can see L2 got raised. Same over here. The next L3. So you can wait for 10 to 15 seconds of duration till the data to be uploaded into the Thingspeak. So as it will take 10 seconds at least to upload the data to the Thingspeak. This is about the open circuit. And coming to the short circuit, just in this one is the ground. Okay, so I'm making short across the load. This is across the load connected parallelly, right? So when we connect this, then automatically, so L1 short circuited, right? Okay, and the next, so we do this L2 short circuited, right? So you can see the -1 for the L1. And here L3. So, but just by providing the hotspot and along with data near this kit, we are going to get the continuously streaming of this Thingspeak, right? We got the L3 also, and it is everything is normal now. So coming to the components, 2 sources with 2 RPS boards, ESP8266, breadboard, and 5 voltage sensors, and this is the fault detection circuitry board along with the loads connected, LCD display, buzzer board, and Arduino Nano board. Right. Thank you.